Hello everyone, this is Dr. Frank Tian Shea, your instructor of BADM 296 Statistics. The textbook we use for this class is Essential Statistics in Business and Economics by Doan and Seward. In this chapter, we'll have an overview of statistics. What is statistics? Why study statistics? Uses of statistics, statistical challenges, writing and presenting reports, critical thinking, and also the statistics as an evolving field. So, what is statistics? Basically, statistics is the science of collecting, organizing, analyzing, interpreting, and presenting data. Some experts prefer to call statistics data science, a trilogy of tasks involving data modeling, analysis, and decision-making. Usually a statistic is a single measure, a number, used to summarize a sample data set. For example, the average height of students in this class is a statistic. A statistician is an expert usually with at least a master's degree in mathematics or statistics, or a trained professional in the related field. Now, why do we study statistics? The first reason is for better communication. Understanding the language of statistics facilitates communication and improves problem solving. The second reason is for computer skills. The use of spreadsheets for data analysis and word processors or presentation software for reports will improve your computer skills. Another reason for studying statistics is for information management, because statistics can help summarize large amounts of data and reveal underlying relationships. Studying statistics can help with technical literacy. There are many career opportunities in growth industries propelled by advanced technology. Studying statistics can help with your career advancement, as statistical literacy can enhance your career mobility. Also, statistics can help firms oversee their suppliers, monitor their internal operations, and identify problems so they can improve quality. Now, how do we use statistics? There are two major kinds of statistics: descriptive and inferential. Descriptive statistics is about the collection, organization, presentation, and the summary of data. Inferential statistics is about generalizing from a sample to a population, estimating unknown parameters, drawing conclusions, and making decisions. The chart on slide number 8 gives a good summary of the two types of statistics. Now, what are the usage of statistics? First, we can use statistics for auditing. For example, in auditing, the auditors cannot possibly examine all the invoices of a firm, but they can sample from, say, over 12,000 invoices to estimate the proportion of incorrectly paid invoices. Statistics is widely used in marketing. We can use stat to identify likely repeat customers for Amazon.com and suggest co-marketing opportunities based on a database of 5 million internet purchases. In healthcare, we can use statistics to evaluate incoming patients using a questionnaire to provide them with the best healthcare with the best value in cost to them. In industrial quality control, statistics can be used to initiate a triple inspection program, setting penalties for workers who produce poor quality output. In purchasing, we can use stat to determine the defect rate of a shipment and whether that rate has changed significantly over time. In medicine, stat can be used to determine whether a new drug is really better than the placebo or if the difference is due to chance. Statistics can be used in forecasting, whereas people can manage inventory by forecasting consumer demand. In product warranty, stat can be used to determine the average dollar cost of engine warranty claims on new hybrid engine. There are statistical challenges as well. Excuse me. The ideal data analyst should be technically current, that is, software-wise, can communicate well, is very proactive, and has a broad outlook, is very flexible, focuses on the main problem, meets deadlines, knows his or her limitation, and is willing to ask for help, can deal with imperfect information, and has professional integrity. Another statistical challenge is to work with imperfect data. When you do, state any assumptions and limitations, and use generally accepted statistical tests to detect unusual data points or to deal with missing data. Yet another challenge is to deal with the practical constraints. You will face constraints on the type and quantity of data you can collect. In using statistics, one should be upholding ethical standards, know and follow accepted procedures, maintain data integrity, carry out accurate calculations, report procedures, protect confidentiality, set sources and financial support. Sometimes you may need to use consultants. Hire consultants at the beginning of the project, when your team lacks certain skills or when an unbiased or informed view is needed. When writing and presenting reports, use pictures. Pictures help make the point, as shown on slide number 17. About critical thinking. Statistics is an essential part of critical thinking because it allows us to test an idea against empirical evidence. Empirical data represent data collected through observation and experiments. But there are also pitfalls in using statistics in critical thinking. Pitfall 1. Making conclusions about a large population from a small sample. Pitfall number 2 is making conclusions from non-random samples. Pitfall number 3, making conclusions from rare events such as winning the lottery. Pitfall number 4 is using poor survey methodologies. Pitfall number 5, assuming a causal link based on observations. Pitfall number 6 is making generalizations about individuals from observations about groups. Pitfall number 7 is to introduce unconscious bias. Pitfall number 8 is significance versus importance. Sometimes statistically significant effects may lack practical importance. Finally, we have to realize that statistics is an evolving field. Statistics is a relatively young field, having been developed mostly during the 20th century. Its mathematical frontiers continue to expand with the aid of computers. There are some major recent developments in statistics, including exploratory data analysis, or EDA, computer-intensive statistics, design of experiments, robust product design, advanced Bayesian methods, and graphical methods, and more. So that's all for Chapter 1. Please continue to Chapter 2.